Hello everyone, so now I'm going to explain the question number 3 of Biweekly Contest 70, which is K highest ranked items within a price range. I know it's a bit late, but I think my approach is quite easy. So you'll find the code in the description. So let's move on to the question. The question says that we have a 2D integer array of grid size m into n, where 0 represent a wall we cannot pass through, 1 represent an empty cell that you can freely move to and fro, and all other positive integer represent the price of an item in that cell, which you can use to freely move from one side to the side. It takes one step to travel between adjacent grid cells. So what's here important given is that we have to take care of the pricing range. It is from low to high, both inclusive, and we will given we are provided a starting point which is inside for the matrix to process our query. And next we are given we are interested in the positions of the k highest ranked items which are within the given price range, and they will be sorted according to the criteria of distance. Whichever has the shortest distance will have a higher rank. The one which have a lower price will have a higher rank in the price range, and the one with the lower number will have a higher rank, and the same in manner will the one with the lower column number will have the higher rank. So let's move on to the example number 1. Here our starting point is given as 0, 0. We have to consider of top 3 position considering all the above 4 parameters, and pricing will be from 2 to 5. We'll start from here. Our approach will be BFS. We'll move on to this point and this point. We'll push both the things in our queue, but the only one which satisfies will be inside our vector array, which is this one. Next we'll move on to the point 3 at a distance of 2, which is at a point of 1, 1. It will also be pushed in the queue and also in the vector because it satisfies our criteria. Then next we'll move on here. Next we'll keep on moving till last point, which satisfies the things, because we can move all on these points and we can't enter in these 0 cells. Later on we will sort them according to the points which are provided here. Okay, so and we'll print the top 3 ranges which comes accordingly. And let's move on to the example number 2. Here we have a bit of twist, which starts at a point 2, 3, which is the last point, and pricing is from 2 to 3. So next we'll move at a point of this and this. We'll push both inside our queue, but both doesn't satisfy the criteria of pricing, so we'll not push it inside our vector. Next we'll move inside to the point at a distance of 2. All these 3 ones, these 2 will be pushed inside our vector. Next we'll move to that distance of 3, and then distance of 4, and then 5. So by this we'll make sure our BFS is complete. So that was all. And then moving on to the third example, it's also quite similar. We'll starting point given as 0, 0 and pricing of 2, 3. So here we'll move at this position, then this, then this, then this, and then this, and then this. So 2, 1 with a distance of 5, which is 3, and 2, 0 with a value of 2 at a distance of 6. We have to print 3, but we don't have any 3 values, so we'll also only print 2. So let's move on to our code. This is our code. We have been provided with a grid, pricing, start, and rank. I've mentioned this one to use inside my moving, so that I can move in all the 4 directions. So that's the thing. I have make sure a queue is there, a vector, an array of int, so that we can push as many elements as I have written here, like 4 or 5. It's very easy to use vector of array int rather than using vector of vector and pushing inside the elements. So we'll first push the starting position, and we'll also keep track of visited element. And next we'll also make sure that we have visited the first starting element. This is the special case. We'll make sure at the last. Then we'll put the distance as 1, and then while queue is not empty, all these codes, which is very much similar to all the time we have written, we'll make sure we calculate the size, and inside of our loop we'll iterate over one by one. We'll pop the element, take inside the p, we'll calculate the new x, new y, and make sure our the cell is at a safe position. It doesn't go beyond our array boundary condition. And then grid new x, new y is not identical to 0. So if it is identical to 0, we will continue the condition, or if it is visited, we'll push all these elements inside our queue and make sure it is visited, and we'll only push all those elements which satisfy the criteria of pricing inside our vector. We'll increase the distance. We'll keep on doing this, and then we'll sort the element accordingly. I have pushed, like, first of all we have to make sure it is the distance, as we can see, distance, pricing, and then row number and column number. So distance, pricing, row number, column number, sorry, here only pricing, row number, and column number. And then sort, and then vector of answer. We can make sure while rank is positive, I have made this k as taken as rank, and then vector of int z dot push back this new x and new y positions, second and third, and then answer dot push back z rank -1, return answer. And this condition special case, which I also wasn't aware of it, but I got through the test cases. Like if the starting position is also come under the pricing range, so we have to consider that position. We have to push it just before, make sure our BFS approach goes. So we'll push back 0, distance, pricing, position, and this row column. So that's all is our approach. Let's make sure it's run. Its answer is there. It's some yeah, so it's accepted. So thank you very much. You will find the code in the description. Thank you very much.